So just want to let you know, when we're graphing these, I'm more focused on not actual you getting the graph perfectly right. I'm more interested in you going ahead and using technology to graph, but being able to look at the graph and describe the different things that are going on and when is it going on. Okay, so that's basically what we've been doing. I haven't had you really graph anything by plugging in points and putting in things. I've basically had you look at graphs and describe them. We've been doing that for a couple of weeks now. So I want you to continue to do that. Now you could have, let's see, a graphing calculator. You could have a graphing calculator like this, and then you can graph your graphs, or you can use Desmos, right? Desmos.com, and then click that graphing calculator, and then you can use this to graph it, because that's where we're going to be doing it. You can't, did I do it again? Did I do it again? So again, you can have a graphing calculator like this, or you can go to Desmos.com and you can use the graphing calculator feature there, okay? Because I'm not interested in, this isn't 20, 30, 40 years ago when you had to do everything on paper. And yes, you do have to do some things on paper. Yes, we did graph quadratics. Mister, why'd you make us graph quadratics then? Because we had to find all the pieces, right? You have to see all the pieces. But what I'm more important for graphing polynomials, because it is more difficult to graph polynomials than it is to do just quadratics, because quadratic is a polynomial, but those are the easier ones. You find the line of symmetry, find the vertex, x-intercepts, and so on, and you graph and you get a nice picture. Polynomials a lot of different things can happen. So first thing we looked at was, right, the leading coefficient. That's going to be important to understanding what's going on in some of these graphs, right? Sometimes you'll be able to look at a polynomial and without doing anything, without even graphing it on a graphing calculator or whatever, you'll be able to tell a few things, okay? And one of those things is the degree and the leading coefficient. That's the first thing we talked about, right, was the degree and the leading coefficient. Because those tell us things. And the degree, I know we were talking about this, the degree tells you the potential for how many times it's going to cross the x-axis. Like if it's a fourth degree polynomial, it's probably going to hit the x-axis 4 times, like this. If it's a fourth degree polynomial, you'll see, here's my x and y axis, 1, 2, 3, 4, right? What do you notice here? Okay. You see how I did 4? Look at the end behavior. Then we talked about end behavior, right? You see this side, and we talked about this yesterday. This side's going down, and this side's going down to negative infinity. And that was with 4. What about if I did it with 3? What happens with 3? 1, 2, 3. Okay, is there a pattern here? Do you notice something here? So let's think about this. So when I have a third degree polynomial, looks like this, hits it 3 times, right? And if you notice the ends, the one on the left side as x approaches negative infinity, the graph is going down to negative infinity. But over here on this side, the graph is going to positive infinity. And that's with 3, okay, the number 3. 4, we just saw, they both were facing the same way, right? I can also do this, 1, 2, 3, 4. They're both facing the same way. What about 5? What do you think 5 is going to happen with 5? If I have a 5 fifth degree polynomial, let's see. 1, 2, 3, 4, 5. Yes, you guys see that? Someone sees it in the chat. If you have an even number, for your degree, these are going to be opposite. If you have, these are going to be the same. If you have an odd number, these are going to be opposite. The end behavior, the stuff that's happening at the end, because then we talked about parent functions. What do each of these functions look like, right? Then we talked about the end behavior, what's happening at the ends. And so now here's a little chart I want us to fill out. Just by looking at the leading coefficient and looking at the degree, can we tell how the ends are going to go? So I want you to take a minute. to think about this. if the leading coefficient, if the number in the front is negative or positive, how does that affect your graph? And if your degree is even or odd, how does that affect your graph? Right, for end behavior. So this is end behaviors. This is talking about what happens on the end behavior, right? There's a little thing right here that says draw sketches to help remember end behavior patterns, right? So what's happening? What's happening? I'm going to give you a minute to fill this out. What do you think is happening? You can put words, you can put a picture, whatever you want, and then we'll talk about this. What happens when the leading coefficient is positive or negative and the degree is even or odd? I'll give you a minute to think about that. Okay. So if you couldn't figure out what this was, or maybe you fill out a couple boxes, that's fine. So what I want to do first is do something you're familiar with. I want to look at even degree, because we spent so much time doing an even degree polynomial and graphing it. What was that polynomial that we worked with for a long time last semester and the beginning of this semester? What kind of equations? Oh, hello? Is my mic working? What kind of equations? They weren't linear. Linear was Algebra 1. But we spent a lot of time graphing these other ones. They were U-shaped graphs called parabolas. What were those? What kind of functions were those? Quadratics. Yes. Yes, thank you. Thank you. You know, there's other people in here that are allowed to speak, right? Okay, so quadratics. So if you notice a quadratic, both sides face the same way, right? So if I have an even degree, so some of you are like, Mister, what do you mean by even degree? Well, the degree is the highest exponent, right? The degree is the highest exponent. So what I mean by that is the highest exponent is 2, 4, 6, 8, 10, ... so on. That means the degree of the polynomial, that means the exponent, the highest exponent of your variable, is an even number, 2, 4, 6, 8. And let's look at the one we've been working with for so long, the second power, the quadratic, right? We've been working with quadratics, and the rest of them behave the same way. And so if your leading coefficient, if the number in the front was positive, remember if your A was positive, which way was it facing? Was it facing up or facing down, your parabola? Not everyone at once. Please. Is anyone there? Just because I took a little break and I had to leave and help my son, did everyone fall asleep? When the leading coefficient, when the number in the front of a quadratic was positive, which way did the parabola face? Did it face up like a happy face or down like a sad face? It faced up. Thank you. Yes, there we go. We're awake now. So looking at the end behavior, each side faced up, right? So we can say both sides go to positive infinity, right? And if we have an even degree, both sides always match. Both sides always match, right? If one's facing up, the other one's facing up. If the other one's facing down, then both of them are facing down. And if it's negative, both sides are facing down, or the ends, we should say both ends, right? Both ends go to negative infinity, right? So for even degrees, it's nice. Both ends are going to face the same way. They're either both going to go to positive infinity or both go to negative infinity. And what's going to determine that? The leading coefficient. The leading coefficient. Okay, what about odd degrees? Well, odd degrees, so again right here, you know how it says both sides match? I should say both ends match, right? And for odd degrees are 1, 3, 5, 7, 9, 11, ... And for odd degrees, both ends are opposite. If one end is facing up, the other end is facing down. Does that make sense? So odd degree. Now, let's think about it. If we have an odd degree, that means to the third power. And the leading coefficient is positive. Right? So if the leading coefficient is positive, well, then from the negative side, I'm going to be going like this. Right? Because if I put in negative x's, right, going this way is negative x's, right? So if I put in negative x's to an odd power, negative to an odd power stays negative. And so that means this side is going positive infinity. Okay. Now, if I have an odd degree and a negative leading coefficient, then I'm going to do the opposite. This side is positive infinity. This side is negative infinity. Right, so right here, as x approaches negative infinity, f of x is going down on this side, and as x approaches positive infinity, f of x is going up. And then as x approaches negative infinity over here, then f of x is going up. And then as x approaches positive infinity over here, f of x is going down on this side. So here's a little chart. Now, you don't have to memorize this chart. If this chart helps you, great. If this chart doesn't help you, and you're like, Mister, I like doing it the way we were doing it before, I just graph it and I look at it, that's fine too. Okay, so I'll zoom in a little bit as much as I can. Yes, I know it's blurry. Again, the video, and yes, I will put in the video today. I will put in the video today. It will be a lot clearer. Okay, if you want me to zoom in on this one first? Let me zoom in on this one first. And then I'll zoom in on the... Okay, like this. Is that clearer? Is that better? Okay, then I'll do the other one in a second. We'll do the odd degree. Okay, so again, as I was saying off camera, because it was on pause, this chart may or may not make sense to you. It may confuse you more. This chart is meant for you to be able to look at a function and tell the end behavior without having to graph it, right? You just look at the leading coefficient and the degree. Okay, so this chart can help you. So you can always, you guys are welcome to use this chart whenever you're doing your homework, classwork, quizzes, tests. You can always use your notes. Okay. So some of you may say, Mister, I don't like this chart. I'm going to just graph it and then describe the end behavior that way. That's fine. If I ask you to describe end behavior and you just want to do a picture, you want to graph it and look at the picture, as long as you can describe end behavior, I'm great. Because that's the standard and that's what you need to be able to do, describe. That's what we've been doing for a couple of weeks now. Describe, describe, describe. Okay? But once in a while, I'll give you a picture like this and ask you what's happening with this graph. What's the leading coefficient, right? What is the leading coefficient? Is it positive or negative? And what's the degree? Right? So if you look here and you go, oh, wait a second, mister, I got this. I got one of them. They're both facing the same way. So the degree is even. And that makes sense. Even, these two are even, the degree is even. See that? These two are the same, the degree is even. Now they're both facing down. They're both going to negative infinity. So that means my leading coefficient is negative, right? We get that frown. Okay, so when they're facing the same way, I think that's the easier one because they're facing the same way. If they're both facing up, the leading coefficient is positive. If they're both facing down, the leading coefficient is negative. Or if I want to say it more technically, if they're both approaching positive infinity, it's positive. If they're both approaching negative infinity, it's negative. But when we look at something like this, we have one going this way, one going that way, one going to negative infinity, and then to the right going to positive infinity, right? Or let's say it more technically, as x approaches positive infinity, f of x also approaches positive infinity. As x approaches negative infinity, as it goes backwards, My graph is approaching negative infinity. So when these match, we have, so we know this is an odd degree, right? Because they don't match. But when when they match, when as x approaches positive infinity, y approaches positive infinity, as x approaches negative, when those match, then we have a positive leading coefficient. Oh my gosh. There we go. Right, and we can just look up here and see that that's happening right here. We have negative infinity to the left, positive infinity to the right, negative infinity to the left. So we just match it to the graph or to the chart. Okay, so use the chart. If I'm asking you to tell me what's going on with these graphs, the degree and the coefficients, you can match it to the chart. Okay, any questions? Okay, we have about 7 minutes. I want to talk about this next page with the things we're going to talk about. We'll talk more about it tomorrow. And I will put the homework up. When we look here, we got to look at turning points, right? So now that we looked at the ends, right? We looked at the ends. Now we're going to start looking at what's going on in the middle parts, Okay, and yes, you're just going to have to describe what's going on. You're going to go ahead and be able to graph it on your graphing calculator or in Desmos. Or if you don't like Desmos, you can Google graphing calculator, and you'll see a whole bunch of different graphing calculators online. But we're going to talk about the turning points. What do you guys think I mean by turning points? Can anyone guess? What do I mean by turning points? Can we get someone else speaking? We have the same like 4 or 5 people speaking. You know what I haven't implemented this semester or this year at all? The wheel. Right? The wheel. Do you guys remember the wheel, those of you that had me before? I haven't done the wheel yet. Maybe I should start doing the wheel. What do you think? And then once it picks you, it takes you off the wheel, and then you won't get picked again until everyone else has been chosen. Yes? Okay, we need to start doing the wheel. I agree, because I'm having the same 4 or 5 people. Okay, thank you. I got someone else. Someone asked, is it when it begins to curve? Yes, a turning point is exactly that. When it turns, you see, when it changes from, and I love that you guys notice this. The graph right here is increasing. And now what's the graph doing after this turning point? It's decreasing. Then we have another turning point, and then now it is increasing again. So one way to describe it is when it begins to curve. Another way to describe it is when the graph changes from increasing to decreasing. Now you see in the purple part, it's increasing, and then the green part is decreasing. What's happening at that point? Is it increasing or decreasing at that point? The turning point. Right? Before the turning point, it's purple, it's increasing. After the turning point, it's green, decreasing. What's happening at the turning point? Is it increasing or decreasing at the turning point? Hello, is my mic on? Neither. Very good. It's not doing either. It's doing neither. It's kind of like when you throw a ball into the air. It's going up, 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 and then it stops. And then down, 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 down. Okay, at that point, that turning point, it's neither increasing or decreasing. That's where it stops. Right? Now, if I could teach you a little calculus, it would take 10 minutes. I could teach you a little calculus for you to be able to find that turning point. Right? But we're going to do it a little easier. I'm not going to teach you calculus because it's not part of the standards. Maybe I'll have a after school class really quick. Those of you that want to learn the calculus method to find that exact point. Maybe I'll have a little 10, 15 minute class after school one day Those of you that want to just dive into a little piece of calculus so we can find that point. Because that's an interesting point in calculus. That's easy to find. Or you just get your handy dandy calculator and you type it in, and then you'll get your curve. And then you can, I don't know if you've noticed this in calculators, you can trace. I think you can do that here. So if I go here and I say x cubed minus, 2x squared plus 3. There you go. So if you look at here, you see, I can't zoom in. I can put my finger on the graph, and you see that? Do you guys see that? Oh, you guys can't see anything. Okay, let me switch it. So when you graph on Desmos, if you want to know a point, you just put your finger there, and there's the point. You put your finger anywhere, or you see how I clicked on that turning point? You see 0.3 is a turning point, and then 1.33 is. So what I love about, and then you can find the x-intercepts too. Bam, you just put your finger on there, and then you can trace, and you can find any point on the graph you want. Isn't technology great? So I'm not going to spend it's the school's calculator. That's the school's calculator, but it's a TI-84. It's a color screen. It's a really nice calculator. I have a stack of calculators over there. Have you seen? Let me show you. Hold on. When I was in high school, and I still have it, this is the calculator I had. This graphing calculator. Oh, I don't think there's batteries in it. But yeah, this is the TI-81. Back in 1991, I bought this. This is my actual high school. Oh, I threw some stickers on it after. But yeah, this is my actual high school calculator. I've saved it all these years. If you look in here, I wrote some formulas. No, I wasn't cheating. I just would always need a surface to write on, and sometimes I didn't have paper, so I'd have to write on stuff. So yeah, this is my high school calculator. So not as fancy as this one. So yeah, we did have graphing calculators back. I'm not that old. Well, I mean, I am, but we had graphing calculators when I was in high school too. But they still made us do everything by hand. I think that's a waste of time when we have technology to graph for us. I think time is better spent being able to look at this graph and figuring out, what is this x-intercept? This x-intercept here in this graph, what does that x-intercept mean? -1, 0. What does that mean in this context? What does that turning point 0.3 mean? What does that turning point 1.33, 1.815 mean? Right? What about this point over here? What if I came over here? Well, I want to look at this point right here for some reason. Right? When x is 4, I want to figure what this is. So when x is 4, and then I can just drag till I get to there it is. Really, really close. 4. Y is 35. Okay. What does that mean? So I think we spend more time describing the graph, understanding what's happening from when x is this to x is that, and stuff like that. So that's exactly what I want to do. So I want to look at turning points. So class is over. We will continue this tomorrow. I'm sorry I was talking too much. We will continue this tomorrow. I will put this video up for any of you who want to talk about this chart and behavior. Tomorrow we're going to talk about turning points. And then we're going to start graphing using a graphing calculator or a graphing technology and start filling in all this stuff. You see all this stuff? This is the important stuff. Can you find this stuff? I don't care if you can graph it by hand. That's not a skill we need anymore. Can you tell me when all this stuff is happening? So we'll do this tomorrow, okay? All right, everyone, take care, and I'll see you all tomorrow.